All right, this is Professor Pelton. This is part 3 of chapter 3, section 2. So we're going to talk about domain of functions. What can I actually plug in that'll actually work? What can't I work? So things you need to be looking for are denominators and even roots. There are other things to look for, like in trigonometry. We're not doing those here yet. Trigonometry will be a separate chapter. And so will logarithms and a few other things that have domain restrictions. The main domain restrictions we're looking for right now are denominators and even roots. So this first one has no denominator, no even roots. So I can plug in any value I want for x, and it'll give me an answer back. So for every input, there is an output. So my domain is basically everything. There's no restrictions on what I can plug in. Okay. However, the next one does have a denominator, and the problem is the denominators cannot be 0, correct? We cannot divide by 0. So using that fact, I'll do some basic algebra. And do 1x, 1x. So 1 times negative 3 is negative 3, which is 1 times 3 or 1 times 3, where one of these has to be negative. So it's going to be positive 1 and negative 3 as the appropriate factors. Set that equal to 0. So x plus 1 is 0 and x minus 3 is 0. So x is negative 1 and x is 3. And those are the values that x can't be because that would make the denominator 0. So my domain, okay, going least to greatest, is negative infinity to negative 2. I'm sorry, negative 1, union, negative 1 to 3, union 3 to infinity. So what this is saying is I can be any value except negative 1 and 3 is my domain. Okay, let's try C and D. All right, so C has an even root, has a square root, which is an even root, and you cannot do a square root of a negative number. And therefore, 3x plus 12 must be greater than or equal to 0, because you can be equal to 0, that's fine. So I'm going to minus 12. So 3x is greater than or equal to negative 12, and if I divide by 3, x must be greater than or equal to negative 4, correct? So I can be any value for the input domain, input of x, as long as it's negative 4 or greater, right? So my domain here is negative 4 to infinity. Any value you plug in will actually work here and give you an answer back. Anything that's less than that, so if I plug in a negative 5, that would give me negative 15 plus 12, which is negative 3, and I cannot do the square root of negative 3 and get a real answer. Okay, so the next one, I have a couple issues here. One, this is a radical, right? So this radical, 14 minus 2x must be greater than or equal to 0. And the other problem is it's a denominator. This denominator cannot equal to 0, right? So I need to erase this time because I have two things going on. One, the radical restricts me to being a positive input. The input must output a positive, and it cannot be 0 because it's a denominator. So I'm going to minus 14, minus 14. So negative 2x is greater than negative 14. Move that down. So I'm going to divide by negative 2. So x is less than 7, because remember when you divide by a negative, you switch the sign. So my domain dot dot is less than 7, so negative infinity to 7, right, because it's less than 7 and not including 7. Okay, pause the video, try the student problems for yourself. Okay, so the first one, I look for a denominator, there isn't one. I look for an even root, there isn't one. So there are no domain restrictions here. So my domain is negative infinity to infinity. Okay, so domain on the next one, we look at this. Is there a denominator? No. Is there an even root? No. This is an odd root. So if you look at the graph above on cube roots, no matter what I plugged in, positive or negative, work, correct? In the prior video. And 5x, no matter what I plug in, works there too. So even though there's a lot going on here, there's no actual restrictions on what I can plug in. So no matter what I plug in, I'll get back a real answer. So this one's fine. Okay, so the denominator here, this denominator cannot equal to 0. So x squared minus 49 equals 0. So add 49. So x squared equals 49. And I'll square root. So x equals plus or minus the square root of 49. So x basically cannot equal plus or minus 7 as far as our domain goes, right? So this will be a multi-part domain here. So let's write it up here. So domain, this could be a long one, dot dot, negative infinity to negative 7, union negative 7 to 7, union 7 to infinity. And again, when you write these, always write least to greatest, right? So basically I can be anything I want as far as my domain or my input, as long as it's not 7 or negative 7. Okay, let's move it down and try the next two. Okay, so I have an even root here. Even roots cannot be negative. So 9x minus 27, 27 must be greater than or equal to 0, right? Because it just can't be negative. So I'll add 27. So 9x is greater than or equal to 27. Divide by 9, x must be greater than or equal to 3, right? So my domain is 3 or greater, and you can actually be 3 because you plug in 3, get 0. The square root of 0 is 0, that's fine. Okay, so here's the problem. 24x minus 3x must also be greater than or equal to 0, but this is the denominator, which cannot be 0, so you have to get rid of the equals two parts. I'm going to minus 24, so negative 3x is greater than negative 24, and I'll divide by negative 3. So x is greater than 8 is incorrect, because if you divide by a negative, you need to switch the sign, right? So in fact, my domain is less than 8, so going negative infinity to 8, but nothing greater than 8, because of the fact I have to be less than 8, essentially. All right, that is the end of part 3.